Hey guys, welcome back to Reignited. Now we are again working on our twin charged Magnum project. In our last episode you saw that we started working on our new power plant for the vehicle. This is a 6.4 liter SRT engine. We put a set of brand new forged pistons and rods, a drop-in kit from Modern Muscle Extreme. Now this time around we're installing our brand new camshaft from Melling Performance, and we're going to be working on a little bit of fabrication. Let's get into it. Now, if you did watch that last episode and you're wondering, yes, I did go back and torque down those rod bolts to their final torque spec. Just wanted to ease your mind on that. Let's talk a little bit about the camshaft that we're going to be using for this project. Now, the cam that we have here was generously provided by Melling Performance. Now, this is part of their new lineup of camshafts that they have for the Gen 3 Hemi engine. Now, they do have a couple of camshafts designed for the pre-VVT engines. I'm talking 2003 to 2008 5.7 liters and also the 6.1 liter engines. But this cam here is from their 2009 and up 5.7 and 6.4 lineup. Now they have a stage 1 and a stage 2 camshaft. This one is their stage 2, so it has a little bit more performance there. Now I'll go ahead and list these cam specs for you right now. Valve lift on both intake and exhaust is 575. Now the duration at 50 thousandths lift on the intake side is 213, on the exhaust is 219, and the lobe separation angle is 114. Now what on earth does all of that mean? Well, like I've mentioned to you guys before, I am not exactly a camshaft expert myself. I'm not going to sit here and dissect all these numbers. I do know that this camshaft here is going to be a better solution than what I currently had in the car, which was a factory 6.4 liter camshaft. This is going to give me a little bit more lift, and I think it's going to work better with the fact that I've locked out the VVT on this thing, because the previous engine, having that 6.4 cam, I wasn't able to take advantage of what it was able to do because I didn't have that VVT control. This is going to solve that issue, and I think it's going to make more power on the top end anyway. Now, an important thing to realize here is that Melling recommends with both the stage 1 and the stage 2 camshaft to completely lock out that VVT functionality. This cam is not designed to use that at all, so you will have to install a phaser lock kit. If you don't know where to get one of those, I'll go ahead and include a link to that in the description down below. Now, the truth is you don't have to be a camshaft expert in specifications to decide what kind of a camshaft you want for your engine. What you really need to be thinking about is, what am I going to be using this vehicle for? Now, one of the mistakes I see a ton of people make, and including me, I made this mistake when I was younger as well, was I want the biggest, baddest camshaft I can buy, because in your head that equates that it makes the most power. But we have to think about how exactly it is that camshafts are working. What is it that they are doing? Well, in my VVT video I did a couple weeks ago, I explained that by moving that cam timing, you're moving the power band basically down low or up high. So VVT can kind of help you get a little bit the best of both worlds, but at a certain point you're kind of having to choose. If you go with one of these monster camshafts with a lot of lift, you got to get rid of that VVT entirely, and then all your power band is from 4,500 RPM and up. So if that's the case, is that really where you're going to be driving your vehicle most of the time? Well, for most people, the answer to that is no. So you kind of want a more streetable camshaft. And I'm in that same boat. I want a more streetable camshaft as well. I want this car to be a street car that does some track use. So for me, it made a lot more sense to go with a more mild cam such as this. Now, especially when you go with a hyper aggressive camshaft, there's also a number of other considerations you have to take into effect. Number one, because you're going to an extremely high lift camshaft, well, you need to make sure that your pistons have some valve reliefs in there so that those valves won't contact the pistons. Secondly, you're going to need to change out your valve springs themselves, make sure they can accommodate all of that extra lift. So the prices add up really fast when you go with one of these super aggressive camshafts, and it may not even be the characteristics that you want anyway. Now for myself, going with this more mild camshaft means that I can stick with these stock 6.4 SRT valve springs. These are plenty capable of handling the kind of lift that this camshaft will put out. I already have the valve reliefs in those forged pistons, so I'm not worried about that. I think this is going to be a great compromise and still make great power in the vehicle it's going into. Now, all the time I have people messaging me and saying, what kind of camshaft do you think I should get for my vehicle with this kind of driving? And I love the fact that they want to talk to me about that. But as I mentioned, I'm not exactly a camshaft expert myself. I don't have a ton of experience with different aftermarket camshafts. I haven't dynoed them or anything, so I can't really be telling you guys which is best for one scenario or another. My advice to you is to contact these companies directly. Talk to Melling Performance, talk to Comp Cams, get one of their tech guys on the line and say, hey, this is the vehicle that I am planning on using this camshaft in. This is what I want to use it for. What do you think is the best option for me? All right, we've talked about this thing enough. Let's go ahead and get this thing into the engine. All right, camshaft is installed. All right, now we want to put our camshaft thrust plate on. Now this only goes on one way because there is a countersink right here for the bolt heads. So you don't have to worry about putting this thing on backwards. Now we'll put on the timing chain tensioner and the chain guide. Now I feel like I've covered Hemi engine timing quite a bit over the years, but it's always a good subject to get a refresher on. So that's what we're gonna do now. We're gonna set up the timing on this engine, get our timing chain installed, and it's really easy in our case right now because we have the cylinder heads off, so we can actually physically verify that our cylinder number 1 is in the top dead center position. Now, taking a look at our crankshaft timing gear here, it's kind of hard to see, but there is a small dot here on this tooth, one mark, and that dot needs to go at the 6 o'clock position when you're putting this on the crankshaft. Now that we know our crankshaft is in the correct position, with that little dot on the timing gear being at the 6 o'clock position, we want our camshaft to be at the 12 o'clock position. So this little dowel pin here, the locator pin on the camshaft, make sure that's sitting at 12 o'clock. And at that point, we can go ahead and install our timing chain set as a unit. Okay, now looking at the timing chain itself, you can see that there's a set of dual marks right here, and there is a single mark right here. Now this single mark corresponds to the dot tooth on your crankshaft timing gear, and these dual marks here will actually straddle that vertical line mark right there on the cam sprocket. Now I do want to point out that those marks on the timing chain are not strictly necessary to get lined up with your timing marks. As long as your crankshaft timing mark is at 6 o'clock and your camshaft is at 12 o'clock, that's really all that matters. The links on the chain that are marked are just there as a guide to help you know that you are lined up. So again, not entirely critical to have those lined up. Just make sure cranks at 6 o'clock, cams at 12 o'clock, you'll be in good shape. All right, as I mentioned, you'll want to go ahead and slide these on as a unit. There we go. And on this cam sprocket bolt, we're going to go ahead and torque this down to 90 foot-pounds. There we go. And then now what I like to do is I like to spin the engine over several times. And then what I'll do is I will line up the camshaft sprocket mark, that vertical line in the top of the camshaft sprocket here. I'll line up that mark 12 o'clock, just like it was before. And then I'll verify that with that mark at 12, that our number 1 piston is at TDC. If those two are in line, then I know my timing is dead on. Now, if you take a close look here at the cam sprocket, you can see that vertical line there is at 12 o'clock position. We look at our number 1 piston there, that is at TDC, so we know that our cam timing is correct. Now to install one of the parts I'm most excited about, and that is this brand new Melling pump. This is their 10452 HV pump. It's a 20% higher volume than the stock pump that goes on these things. I'm really excited to install this thing and see what kind of numbers we can get out of it versus the Hellcat pump that I did have on here. Now, obviously, Melling has been so generous in supporting this project, but also in helping out you guys. We had that previous giveaway with that oil pump, and there was such a fantastic response to that Melling talked to me this last time and said, hey, you want to give anything else away? And I said, absolutely, send over whatever you've got. So they sent this over, and I'm actually really excited about this. I'm actually quite jealous of whoever ends up with this because I would like to have this for myself. This is basically an oil pre-luber for your engine. Like if you've ever done a rebuild or anything like that, it is important to actually get some oil into all those passageways before you crank the thing and fire it up. This is a tool that will accomplish that. Now, I don't want to take it out of the box right now. I want to keep this thing sealed for whoever gets it. So I'll go ahead and put a picture on the screen right now of what this thing looks like. I'll give you a link both up top and in the description down below to this thing so you can get a closer look at what exactly this thing does for you and what it's capable of doing. But I'm so excited about having another giveaway here on the channel. I do want to make it a little bit more interesting here. Instead of just putting Melling in the comments down below, I want you to work the word Melling into an interesting sentence of some kind. Just make it a little bit more interesting here. That's literally all you have to do to enter. Just make sure that your comment has Melling somewhere in there and you are automatically entered for this giveaway. Now, I do have a little bit of unfortunate news here, and that is this time around, I'm going to restrict it to just the lower 48 states. I'm not going to be doing anything international with this. The shipping costs are just too high on that, unfortunately. So I apologize to everyone who is not in the lower 48. But for right now, this particular giveaway is just gonna be lower 48. One last point I want to make here, guys. I feel like YouTube has done a better job of it, but we are still sometimes seeing some of those Telegram scammer comments coming up in videos where we have a giveaway. So please don't pay any attention to those. I will not be contacting you and telling you to use Telegram or anything like that. That is not going to happen. More than likely, I'm going to be asking you to use my official email, sales@reignitedtx.com, to actually make that connection. I'll verify it to you and verify that you are the one who has actually won the item, and then we'll orchestrate shipping from there. So again, it's going to be a little bit more legitimate than just some random comment with a bunch of emojis in the comment section. So just a note for you guys. Now it's time to install our lifters here. Now, as you'll recall, we got rid of our MDS system, so these are non-MDS lifters. It doesn't matter if they go in the front or the rear here. If you do have the MDS system, it does matter very specifically where those lifters go. But if you read the back of the lifter tray itself, it will tell you if it goes in the front or the rear of the engine. Now the time has come to install our oil pan gasket / windage tray. Now on the Hemi engine, it kind of doubles as both. I actually really like this design. We very, very rarely see oil pan gasket leaks on these engines. I think this is a good setup. It's also technically reusable, but in my mind, if I have this thing all the way apart, I'm gonna put a new gasket in there. I don't wanna deal with it if this thing leaks. So we're ready to install this thing. The only thing to remember here is that at the rear of the engine, where the rear main seal meets up against the iron block, and at the front of the engine, where the timing cover meets up against the iron block, you'll wanna run a small bead of silicone just on those 4 corners right there before we actually put our oil pan gasket in place. All right, now that we've installed our windage tray here, we can install our oil pump pickup tube. Now this one in particular is an SRT model, and the reason that I can tell that is because it has this extra mounting stud right here, which goes on this front main cap stud that sticks up here. So there's an extra mounting point, gives it some extra rigidity. Now that all sounds nice, but I do have a little bit mixed feelings there because first of all, you don't really need the extra mounting point here. It's not like this oil pump pickup tube goes through so much vibration that it cracks. I have never once in my life seen one of these pickup tubes crack. But also with the regular cars that don't have this extra mounting point, you can very easily unbolt this bolt here and leave the pickup tube in the oil pan and actually change out the oil pump if you need to. With this extra mounting bolt, you have to actually pull the oil pan off to get this pickup tube out and replace the pumps. So a little bit of mixed feelings there, but I'm gonna go ahead and install it as it's designed. Also, another point here is that you want to make sure that you are lubing your oil pump pickup tube O-ring before you install it. If you try to put this in dry, there's a good chance that you could actually pinch that O-ring, perhaps even cut it, which would give you a lower oil pressure than you were expecting. Now when installing your oil pan, it's very easy to actually get these bolts cross-threaded up in there, and these holes are actually very small and these bolts are pretty weak. So my recommendation is when you are putting your oil pan back on, go ahead and start all of the bolts first before you start tightening any of them down. If you start at one end and start tightening them down, by the time you get to the other end, maybe those bolts don't line up perfectly and you think, well, I can probably just straighten it out by running the bolt in, and it's super easy to get these things cross-threaded or even break them off. So again, just start all the bolts first and then tighten them down. And now it's time to get our front timing cover on. Now, because I put on the oil pan before I put on the timing cover, I'm gonna go ahead and put a little bit of that silicone right here in the corners here on the facing edge, and that way we'll make sure to get a good solid seal once that timing cover goes on. Now I did put a new gasket or a new seal in the timing cover already, so it's ready to just slip it right into place. There it is. We finished up with our entire short block assembly here. Now before I drop it back into the vehicle, I'm not going to assemble it any further because I actually like to install it in the car just a short block and then put the heads on. It's very much easier to do it that way than try to fit it in after the fact. But before we do that, there's something I want to address, and that is the belt routing. I just really have never been happy with how the belt routing was done on this vehicle. In my initial revision, I really liked the way it looked. However, I made a mistake and I actually put the tensioner on the drive side of the belt rather than on the slack side. Rookie mistake, absolutely. But when I redesigned it to fix that, I had to route the belt entirely differently, and I've just never been happy with the way it looked. And it does still have a tiny bit of slip because there wasn't a great enough wrap on the alternator itself. What I want to do is I want to go back to the original style belt routing, but install a tensioner in the proper place. Now is the time to do that when I have the engine out. So what I'm going to do, they're going to go ahead and mock the whole rest of the engine together so I can actually get all the pulleys in place and actually mock that up and get that new system designed. So let's start doing that. There it is. We've got our accessory drive basically reinstalled on the engine here so that I can mock things up. Now what I'm going to try to do is I'm going to try to integrate this Chevy LSA tensioner. I like these tensioners a lot. They have quite a bit of force to them, and it's an 8-rib belt, so it should work out well here. Now I just need to fabricate some sort of a mounting system to where I can integrate it into this system and put it over here on the slack side of the belt to provide proper tension, and hopefully this way achieve the aesthetic look that I'm going for, but also have it be functional as well. Now it's been a little bit since I've had a chance to bust out the welder, and I gotta tell you, I'm itching to build something, so that's what we're gonna get into next. All right, made a real good start with our tensioner here. Now, I don't particularly love how close it is to this pulley here. Aesthetically, I don't think that is fantastic, but there's really nowhere else I could put this thing. It's a rather large tensioner. And you can see I swapped it around. I'm no longer using the grooved pulley. I swapped it to this smooth pulley because I had to go on the back side of the belt rather than on the inside of the belt. This will help give it the real proper tension. Now, really, it bolts, the bracketry actually bolts to the front of the water pump here. And you can see we have some bracing along the back here. I'm going to also make one more brace. I'm not sure if I'm going to make it to here or down to the head so we can triangulate it a little bit. There's a lot of force on this pulley. I don't want to have any kind of flexing at all. But I think this is a pretty good start here. and it really does put a ton of tension on the belt when it's all on there. A little more cutting, grinding, and welding later, and I have what I think is going to be our optimum tensioner setup here. Now, I did have to modify it from that last clip there. It just wasn't quite in the right position, and overall, I'm pretty happy with how it is now. I don't think it's as aesthetically pleasing as it was previously, but I definitely think functionality-wise, it's going to be really strong. Now, the only unfortunate thing here currently is that with the belt tensioned, it actually comes really close to where it crosses under this idler right here. So the only way to actually change that is to put a little bit more tension on the belt itself. And so what I'm thinking I'm going to do here is I'm going to add a spacer to the power steering mount here where it mounts to the timing cover and push the whole thing down just enough to give me a little bit more tension there. Now you might say, well, why don't you just try using a different serpentine belt, a smaller belt? Well, that was my original intention. I did actually have a smaller belt initially, but with this new design routing here, it just wouldn't fit over all of the pulleys, even the tensioner fully brought back. So it just wasn't quite long enough. And this belt happens to be the very next belt size available in this 8-rib belt. I think it's about 3/4 of an inch longer than the other one. And unfortunately, that's just a little bit too long. So the tolerances are obviously very tight here. So I think adding the spacer to the power steering pump here, pushing that down is going to be the optimum outcome to actually get just a little bit more tension on this belt and actually push this thing back so it's not quite running right up against this other one. We have absolutely optimum wrap here on the supercharger pulley itself. This is close to probably 320 degrees of wrap on the supercharger pulley, so I definitely don't think I'm going to be running into any slip issues right there. The alternator, I'm still looking about 180 degrees wrap there. So I really think this is going to be a good situation for reliability and longevity with this system. Now, if you'll remember, the entire point of this exercise was about more than just having proper wrap on all of our pulleys here. It was about serviceability. The way the belt routing was before, I had to be underneath the vehicle to detension it and actually get the belt on and off. Certainly not ideal. This situation is going to be much better because it's super easy, right up front, right up top. I can just detension it, pull the belt on and off, no problem at all. So serviceability, much improved with this setup. Now that we've got this major project knocked out, our next step in our next episode is to get this engine back into the car. I don't want to promise it right now, but there's a pretty good chance that in the next episode, you will actually see this engine running again. Honestly, it may seem like there's a lot of work to get from here to that point. It's not that bad. It's mainly just a lot of reassembly, which isn't really a big deal. The fabrication stuff is what takes absolutely the most time. And there's a little bit more fab to do, but only after we get the engine back in, and then I can actually make some strides from there. So until that time, as always, you guys, thank you so much for following along, sticking with this project. We'll see you next time on Reignited.